Thank you very much for the invitation. So this is basically a dialogue between CWI and the Royal College of Arts. And basically what we are trying to do, if my computer doesn't fall down and breaks, which I do very often, we are going to talk a bit about what we've been doing at CWI in terms of physiological computing and sensors and collaborations with the smart textiles and all the rest. We haven't done very much on soft robotics, I have to say, just to clarify. But anyway, we will see. We have a team here. We are 4 people, so I'm going to do a bit of the introduction of CWI and the group. And then each of the members of the group, they will be developing more some of the topics. Pablo Cesar, I work for CWI. That's the National Research Center of Computer Science and Mathematics. That's in the Netherlands. So you know what is Python? Who has used Python? No? One. Ooh. Awesome. Well, it's a very important programming language, and actually it started at CWI, and here you have the second programmer of Python there. So CWI is basically a national research center. We are around 200 people. 70% of our budget comes from the government. The other come from collaborations and from various different projects. And we are very proud of our history. And certainly it was very important in terms of connecting the internet to Europe. It was very important in programming languages. It was very important in the dikes, as you can imagine, in the Netherlands. That's essential. That is what is CWI. This is the group that we have. So I'm the leader of this group, and we are around 15 people. As you can see, yeah, we go for now there is a lot of more people in there because we have a lot of students. And we like a lot partying, as you can see in there. But we have a large group that is looking into a very different number of topics, and I'm getting a bit of noise there. Yeah, thank you. And the number of topics that we do goes from what we call social-iot, which is more about the social aspect and how you communicate and all the sensors. Smart textiles, as we are going to be discussing here for quite some time. And then we have a number of other research topics. So this is a group that started as a networking group, and basically it was about networking and delivery of media. And then it moved little by little into other areas. So for example, we study a lot quality of experience, which is what stands there. And it's trying to understand what is the quality of experience of people consuming media. We do a lot on VR and AR and immersive media. We work a lot as well with networking, so we still do the work on the optimization of the network, and I assume something is going to come at some point in terms of all the systems and all the challenges that there are in that area. And we do a lot on server experiences and multi-screen production. So it's a group that we look at the media, and what we do is that we put the human in the loop. That's our main concern and how we do things. And basically, we try to put our systems in the wild, and by putting the system in the wild, then we study the impact on the people or the impact on the users. As said before, 70% of the money comes from the government. The other 30% we need to figure out how to get it because we have a lot of students and sometimes we go partying, as I said. We have a lot of collaborations, and this is exactly the type of things that we are starting today to look at. We collaborate with, of course, universities. We collaborate with companies. We participate in all kinds of projects, some national, some European. And yeah, my hope is that by being here, right, with all of you, we can discuss about potential collaborations, how that can work. Can we have projects together? Are the topics that we study similar? What is actually interesting? So very, very quickly to an overview of textiles, and this certainly I don't have to explain. Typically textiles, what is happening is that you have the clothes, and then they can be used for a number of issues, right? Some of them, they are more protection. Some of them, they are more the aesthetics, so extending your performance, becoming stronger, or being capable of doing things that before you were not capable of doing. And one of the things that is coming very much, as you can imagine, is wearable technology with all kinds of devices that you wear around. So what I'm going to be presenting is this part of our work, and then of course the rest of the group, they are going to be talking about other different things. So I'm going to be discussing how we've been creating some physiological sensors. Basically, they are GSRs, so these are basically about your sweat, and how we've been putting those in the wild in various different situations, trying to understand the reaction of people to certain events, like, for example, this one. As I said, our approach, so we are basically computer science or electrical engineering, but still we have a distinct approach on how we do research. And basically what we do is this type of things. And the first thing we do is that we work with experts. Anyone knows, what can this be? It's a party, of course, we party a lot, I know. So this is members of my team with a theater company in Falmouth. So one of the things that we studied, it was distributed theater. So what is distributed theater is basically that you can have actors in different locations and they can have a play together. So what we did is with this theater company, we had one theater play that basically was staged in two places, but it was staged at the same time. And then it was communicating between them, and basically we were creating one play. One of the characteristics of the group is sadly that, is that we go and we work with the people in the theater, with the company, with the actors. We learn from them, we try to understand what are the needs, and then we build the systems, and we actually do that particular play. So this was the one. This was the distributed performance. And basically what we had is that we had two different stages, and then in each stage we had different actors, and then we will have one play. One of the problems that we had in there is that you have audiences in both of the places. So suddenly, if I'm an actor, I can see, right, or I can focus on someone. I know more or less how is this going, right? If I don't have that people in front of me, I have no clue what is the reaction. So we had a problem in there, that it was, well, if you have distributed performances and you have different locations, how can you know something about the reaction of the public in another location in which you are not there? And based on that, this was probably around 2011, is when we started in the group to study all type of sensors in order to understand audiences in different type of situations. So in our approach, if you think about this, for example, distributed performances, or if you think about talks, or if you think about education, we are really focusing on that part of the actually when the experience is happening. So there is a lot of research going on in different parts. Of course, it's just what you do before a performance, what you do after the performance, how you learn about the engagement or about impact, right? I mean, you count the number of tickets, or you count whatever the number of tweets. There are a million ways of doing that. In our case, we are really focusing on that part that is during the performance. And what we do is that we basically bring our sensors. And I'm going to show some examples of how we created a bunch of sensors. We put it, basically, give it to the people around, and then from there, we gather all information about their reaction to a talk, or to a performance, or to any other event. So I'm going to go one by one from the devices that we use to the software that we constructed and to the results that we obtained. So it's just a bit of an overview of how we develop everything. So we created a number of sensors, and there were a number of them and how they work and what they were meaning and what they were measuring. And basically what we decided, because a lot of research in that area, is that GSR, so that's the level of sweat and is distinctive by how much is the difference of sweating, it was a good proxy to understand the reaction of the people. So basically what we did is that we constructed our own sensors. And you can say, well, there are so many sensors out there, why you do that? Well, because we wanted to have full control over the whole thing. And the idea in here is that we will give a sensor to basically each of you, and then we will have some system that will be collecting all the data and will be processing in real time what is the actual general atmosphere of an event. And one of the things that I have is one video from a lecture in which what we did is that we had certain balloons that they were going up and down, and basically what they were showing, it was the atmosphere of that particular event, because they were connected, of course, to a reaction of the people. So we had a bunch of different versions of the sensors. We did learn a lot about how you do these things, and I showed you the first one. So yes, we do these things, right? We love to go to the lab, and we love to actually make things and break a lot of them and try not to burn anyone. But this is one of the first versions of actually our sensors and what we were trying to do. Basically, this will be, you will wear it in your hand, and in this case, well, you will have this very, very convenient design. And soon, of course, we noticed that we couldn't do it ourselves. So then what we did is that we went to China, and we went to some certain factories. And what we did is that we actually did the whole process, right? We did the design, we went to a factory, we produced the sensors, and we did a mass production of the sensors, a mass production as in 200, which for us is mass production. Of course, for the factory was not mass production, and we had a lot of problems in other ways. And actually, as a research group, you shouldn't do this type of things of trying to go to a factory and do these things. But anyway, we went there, we created our own sensors, and basically we got this type of sensors that we have in the lab. And these are sensors that basically you can put in here. They have some reason, and then you can put it in your hand. Certainly, it was a Chinese student, so you can see that the style is very much, and of course, this is how it was used in a various different experiments that we ran with them. Right? It was intended for kids. That we had all that they were not for kids. And these are the other ones that they were not intended for kids. So basically what we did in here is that certainly there is no much design in here, as you can see. It's just very, very functional. We try to create sensors that we have full control, and basically why we needed that control. So we needed that control because we wanted to get all the data. And to get in all the data, then we needed a network infrastructure that it will allow us to do so. And I'm talking about hundreds of people at the same time. Right? And distances and other people, the packets come, all of them they are dropped, so you don't get the data, you have troubles. And then what you want to do is to process that data in real time. So the second part is the infrastructure. And this is really part of what Jack was doing, and probably one of the motivators of what he's going to present later on. And I'm not going to go into the details of anything because I don't think it's really even important. But what you need to know in here is that we created a full infrastructure in which basically we could gather data from a lot of people at the same time. And we created an infrastructure that actually will work pretty quickly. So if you go to a theater play, you can imagine that if you want to put all these sensors, the person that is seating the people is not very happy with you taking like 5 minutes to put sensors to people because the play has to start. And you are on their way. So it's a complex situation. So what we did is that we developed a whole system in which, with some optimization, we could gather data from large crowds at the same time, and we could actually process it in real time and really understand what's going on, right? What is the reaction of the people to that particular event? This is just a figure, but it's not really important. This is much interesting and beautiful. And there is all this research that we did in terms of where do you put the servers, where would you put whatever infrastructure that you need, how you connect everything, a number of interfaces that we developed, because of course we noticed that at some point you have all these sensors, but half of them, they don't work, obviously, because they are broken, or the cable is wrong, or the people just move, or the people did something else. So we created all kind of interfaces as well in order to do a control of how the sensors are working, how you put them, how that works, and where it's going. The third part is the software itself. So now you have a bunch of sensors that people is wearing. Now you have an infrastructure that actually can gather data. And now you have all that data and you need to use it somehow. And what we did in there is that we developed a number of solutions for actually processing data in real time, a lot of statistics, a lot of other things. I think Sergio is going to talk more about the particular solutions that we apply in other with more machine learning and more other types of solutions. Basically what we are doing in here, just so if you have all these people, we all have different responses, and actually physiologically the numbers, they are totally different, so you somehow need to identify the peaks and the no peaks, and basically if you know the peaks, you know the moments in which more people were paying attention to a particular event, that if you have a time of this is the theater play, you know, okay, it was this moment, or if it's whatever, it's a concert, or if it's something else. So that's the type of software that we developed. I mean, it's very, very, very simple statistics of trying to figure out the peaks and no peaks of a lot of people at the same time. And the idea in here, of course, is that if you have one stimulus like this one, and you have a lot of people with a peak in the same moment, most probably is not what they are thinking, because it will be difficult that everyone is thinking about something interesting at the same time, but it's actually what is happening outside that is the focus of attention. And we did what, basically what we did is, this is, for example, with Warhorse, with the theater play. And then what we did is that we just map it, right? So now we have all this data, we have the sensors, we process the data, and then we can identify and map what are the moments that they are more interesting, or that the people is paying more attention, the people is more engaged with. And basically all that is the research that it went into the software. And what we do after that, of course, is that then we go to whoever is in charge of the play. It might be the actors, it might be the director, it might be the producer, and we can say, well, you see, that was not the best idea. Oh, that's great. And then we can have a dialogue on how that can improve, or how can we learn about the reactions of the people. There are various different visualizations that we did, because of course, as you can imagine, in these dialogues with the actual producers, or with the actual people in charge of them, then they have different needs and they have different requirements. But at the end of the day, basically all the research was about the same problem. That is, how can you know in a way in which is non-intrusive about the reactions of people to particular events, like, for example, theater plays. And these are just visualizations about what were the moments of more interest or less interest. And of course, we did all kind of research depending on the person, so depending on the sex, the age, and how it was, because of course in Warhorse, this was, I'm going to show a couple of examples later on, but this was Warhorse when they put it in China. So this was together with the National Theatre of China. And then in there, they were very interested about what was the difference in, reactions in comparison to the public in the UK, if it was for kids or not, and all kind of ideas. This is just another visualization. This is about a TV program. And probably you know TV program like The Boys or something similar, in which someone is doing an act, and then you have all these people, and at some point someone has to be kicked out. And typically what you have is the votes of some people, or from the phone, for example, or you have some experts. And what we did in there is that basically if you have the public and then they have their sensors, well, this could be as well as an input to take any decision in the process. So this was one of the visualizations of work that we did in that area. From here, just I'm going to put some examples of where did we put all our infrastructure. And of course, all this gave us a lot of learning, and how have we used it then later on. So one of the examples is Holland Dance. So this is the dance company in the Netherlands. And what I say, what we did is that basically we wire up people during the dance performance. And then what we did is that we get all kind of information. What is very good from here is that typically at the end of a talk or at the end of a play, everyone would clap, right? That's it's not that they like it or not, it's just that we are also human beings and we understand that that's what you should do. With all this technology, what we could do actually is to understand what was the actual reactions of the people, which gave us a lot of knowledge about what it happens when you have Italian dance in the Netherlands without any subtitles or anything, because they had so to learn a lot of things. The second one is what I said. This is Warhorse, and then what is this is that the National Theatre of China, they had a huge play, and it was in Shanghai, and in there basically what they did is that they bring it from the UK. It was very, very important, and then they asked us to be part of the team. And once again, what we had, it was like one part of the theater in which we would basically put sensors to everyone in that part of the theater, and then we will learn much more as I show about the different reactions. Another example is it was a jazz concert, in which this was a jazz concert in one of the institutes in Amsterdam, and we did similar things. That were two bands, and then we put the sensors to the people. We tried to learn, and of course we didn't take into account that alcohol actually plays a big role in your physiological data. Well, it was not necessarily the best thing we could do ever, but it was we learned a lot as well at how things work and they don't. And I'm not going to put this video, but I'm going to put the next one. And the other one we did, it was during some lectures in the institute, in which, as I said before, what we had, it was more a physical object that it moved, and basically that physical object was a number of balloons that they were connected to the people. So then you will have in real time a real response to how people is actually reacting to a talk, and then the balloons will be just the atmosphere, right? They will go up or down, and at some point, if no one is interested, they will just explode. So everyone will be at the same time like, oh, what's going on? Maybe I should start listening there. In that case, what we had is that we had as well one first prototype of what it became later on, all our research with a textile designer in the Netherlands that is called Bybore. So we had a jacket, and the jacket had certain other sensors as well. So we will have a lot of other information about the people and their reactions. And this is one example. So we created an interface that it was in a mobile phone in which you could see, right? And this is just telling, you cannot see very well from there, but you can see in there it was about the reaction of the speaker and about the reaction of the people where the talk was happening. Here you can see a bit more about the whole thing, which you can see the balloons and how the balloons go up or down, right? And you can see basically the people on the speaker. That's the particular jacket which I agree with you didn't fit him very well. I do have a video about this, so I'm just going to put it very quickly because I think it's interesting to...
Ever wonder about the actual impact of your talk, speech, or lecture? How can the atmosphere of an event become tangible? This installation is a unique collaboration between the digital artist, Lilia Perez Romero, in charge of the concept and its development, and CWI, in charge of the infrastructure and the technology behind the sensors. Tangible Air is an electromechanical installation or shape-changing sculpture envisioned for the visualization of the aggregated sensor data of audiences.
The idea came from a brainstorming session that we had between the CWI Distributed and Interactive Systems Group, Bybore, and myself. The installation is like an array of balloons. Each balloon corresponds to one audience member. And that person, that audience member, is wearing a sensor that is measuring the degree of engagement of that person in the talk that they are attending to. Normally, the engagement starts in a high level. So the balloons start in a high level. It's like a movable sculpture of balloons. But as the audience members become bored, disengaged, sleepy, or somehow distracted, the balloon which corresponds to that person becomes lower and lower and lower and lower. And if it reaches point 0, then a needle makes it burst in such a way that hopefully the sound will engage the audience members again and make all the balloons in the installation go up again. One of the main usages was to affect the environment through the wearable computers in such a way that, for example, people who attend a party and are wearing sensors could affect the music that the DJ is playing, because he will have real data sent by their wearable or their textiles about their mood and their heart rate or nervousness or engagement, etc.
Based on do-it-yourself principles, stepper motors, Arduinos, custom-made GSR sensors, the installation explores the convergence of smart cities and environments and connected citizens, providing a tangible way of visualizing the invisible. It is a glimpse to the future where big data, creativity, and technology converge. Tangible Air was presented to the public at the CWI and Industry event during a conference about wearable technology given by the well-known Dutch fashion firm Bybore.
So those are the type of things that we do, right? At the end of the day, what we are trying to do is that we understand about the reaction of people, and then we try to influence. And it might be by a very, very visual and I mean something big like a bunch of balloons, but it might be through other kind of interfaces. This is one other example of the collaboration with Bybore, and it was the car of the future. So this was I think it was a design award from Volvo, or competition, sorry. And then basically what they requested is, well, what you will do with the car of the future, right? And the main idea was, well, it's self-driving, right? So you actually don't have to drive. So then what we studied or explored or tried to do was to create some environments and some textiles that basically they will be adaptable and they will move. So then you could basically become whatever you wanted to do. It will adapt to yourself. It will adapt to your moment. And at some point, it will actually create, if you wanted a chair, if you wanted just to lay down and sleep, or if you wanted to read something. So we created as well one other experiment in there that fortunately we didn't win the award, but we were very, very close to that. And I have just one final video that is more about the future and more about what the other people is going to be talking about. And it's how are we actually from here moving to the next stages. So where do we want to go with all the smart textiles and all the sensors that we are developing. So just 1 second, the video.
On June 4th, 2015, in the Science Park of Amsterdam, an experiment was conducted. The experiment was initiated by Bijbore in partnership with Distributed and Interactive Systems of CWI. It involved motion sensors wired on the hands of a selected group of spectators attending a presentation. The goal was to sense their level of engagement. At the same time, the designer was also connected to biometric, heart rate, and motion sensors which were embedded in his sweater. His garment was made a device for recording data by integrating conductive yarns through a signature knitting process. During the presentation, the collected data was directly visualized on a screen, so everyone could witness the mental and physical conditions of those participating in the experiment. That day, human behavior was tracked, recorded, and processed into quantitative data by a sweater. But moreover, it's the establishment of a platform that communicated and exchanged personal data by using real wearable technology.
Good. So this is basically an introduction of what we've been doing, how we've been working. It's a lot of the sensor technology that we develop and a lot of the vision of how can you use those sensors in order to better understand people, and then how can you use that in various different environments. Next, I assume, is Stephen is going to be talking. And he's going to be talking more about a general framework for the infrastructure. I think Jack is going to continue that. And then Sergio is going to be talking more about our next collaborations with Bijbore and a number of other experiments that we've been doing and that we will be doing in the future. So, thank you. That was all for me.